Hello, welcome to a coding challenge. Now, I know what you're thinking. I mean, I don't know what you're thinking, but I know what I'm thinking. That looks like coding challenge number 92, XOR, which is probably one of the less interesting, creative, like sort of just technical coding challenge demonstrations that you've done. Why are you doing it again? Well, Eric from the Coding Train community writes a nice explanation, because I was, just before I started this, having a real hang-up about this. Sometimes it's important when learning something new to base your exploration around an example which is fairly trivial and you understand intimately well. So here's the thing. I am learning something new. Well, come back here. And the thing that I am learning something new is this TensorFlow.js thing. And wouldn't it be fun to make, like, play Pac-Man with it, or the emoji scavenger hunt project, or Teachable Machine, or play a piano with it, all these things. Ooh, PoseNet, oh my God, I want to get to this. And I could just sort of go there right now. I will get there eventually. But I'm trying to learn the basics of how the library works, and I'm trying to step through this slowly. So I will say that if you're watching this video right now, where you are is not necessarily in the most beginner-friendly place, because I'm working with TensorFlow.js natively to implement basically like a weird math problem. It's not that weird of a problem, actually, but a very basic, trivial math problem, just to see how TensorFlow.js works. That's what I'm trying to do in this coding challenge. And in about 20 or 30 minutes, I'll be coding. This coding challenge is, just look, it's probably like 4 hours and 72 minutes long, which is why would I say 72 minutes, because that's 5 hours and 12 minutes, but I don't know what's going on. But the trajectory that I'm on is I'm going to start doing some stuff, inching my way towards, oh, let's actually use some data. Let's use some more data and maybe some images. And so I've got a bunch of things that I'm stepping through, and I'm trying to get to the point where I'm going to use this other machine learning library called ML5, which at the time of this recording hasn't really officially been released yet, but builds on top of TensorFlow.js. Thank you, everyone who made TensorFlow.js, wherever you are, to try to create some more accessible interfaces to some of the algorithms and models things that you can do with TensorFlow.js without having to do the lower level memory management and math operations stuff. So all of that is coming, and I just took a lot of time in this coding challenge to say that to you. So, but as much as I kind of I'm not so sure, but what I'm going to do, so why is XOR? So here's the thing, this is why. I need an example. This is the first time I'm going to ever, in any of my videos, except for the other one that I made, but this is the first time that I'm actually going to use the TF layers API to train a model with a data set to produce a certain output, okay? I did 2 tutorials about what the TF layers API is. You could pause now and go and watch those and then come back here. But in those videos, I didn't actually do anything with TF layers. I just sort of talked through and typed out some code. So the problem that I want to solve, and apologies for explaining this probably for like the 15th time on this YouTube channel, is very well known from machine learning, XOR, because when the original perceptron was invented, the single perceptron, the model of an individual neuron that could receive inputs and generate an output, it could not solve XOR. It just couldn't. It's not a linearly separable problem, and I've talked about that in other videos about why we need multi-layer perceptrons. So the nice thing about XOR is I can diagram for you the architecture of the model that we need to create. There are 2 inputs. There is 1 output. So the inputs to the XOR problem are true and false values. So unlike, so if I made a little truth table, and, or, XOR, right? I can have true and true, true, false, false, true, false, false. An AND operation would only ever give me true when both are true. False, false, false. An OR operation would only ever give me, would give me true if just one of them is true. True, 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 false. Can you even see that? I can't see on my monitor, but hopefully you can. Now, XOR, the X for exclusive, gives me true only if 1 is true. They can't both be true, only 1. So in that case, I get false, true, true, false. And the idea of linearly separable comes up here because I can draw a line here to separate true from false. I can draw a line here to separate true from false. But here, I can't draw a line. I could do this. But I can't draw a single line to separate true from false. We need a more sophisticated model with a hidden layer. So the inputs are things like a 1 and a 0. Feed forward into the hidden layer, activate, feed to the output, and the output should be a 0 or a 1. Because ultimately I'm going to visualize the output as grayscale values, and I want to see grayscale values all the way between 0 and 1. It's the same thing I did in the previous coding challenge, if you happen to have watched that one. All right, so now I'm going to also do something where I start from the code from the previous coding challenge. And so we can see there's this idea of training data. The inputs to the XOR problem are 0, 0 gives me a 0, 0, 1 gives me a 1, 1, 0 gives me a 1, and 1, 1 gives me a 0. This is the training data. And in my previous version of this, I used my own neural network library. So in theory, I'm going to get rid of the idea of a learning rate slider, we can add that back in later. But let me get rid of the learning rate slider. Basically, I want to do exactly the same thing. The difference is I'm going to say neural network equals tf layers sequential. And maybe I'll call this the model instead of neural network. So the idea, oh, this is neural network here. So the idea here is that I want to replace my neural network library with TensorFlow.js. And so this, for me, what the usefulness of this video is of me learning. I spent all this time trying to build my own rather sort of terrible neural network JavaScript library. And going through that was sort of helpful in thinking about how the stuff works. Now if I can translate that into TensorFlow.js, things are going to hopefully start to settle and make more sense into my brain. OK, so now we need to, this constructor here said, and let's just put this back to this. This constructor here said, make a neural network with 2 inputs, 2 hidden nodes, and 1 output. So I need to duplicate that idea here with TF layers. So let's go to the TensorFlow.js API reference. And we're going to scroll down to TF layers. And what I want to make is a dense layer. TF layers.dense. A dense layer is a fully connected layer. So what I'm going to do is I am going to say let hidden equal tf layers.dense. And then I can put inside there an object that has the parameters of how I want to configure that layer. And so how do I want to configure it? The 2 things that I really need to do is, this is the hidden layer, right? I need to give it an input shape. Right? I need to say what's coming in. What's coming in, that's what this is here. I need to say how many nodes it has. That's the number of units. And then it probably has a default one, but I can specify an activation function. And again, I'm just going to use sigmoid as this historical activation function that I've been using in all my videos to date. I'm going to soon talk about softmax, what that is, as well as some other activation functions like relu, which is maybe more commonly used. Okay. By the way, nobody pronounces it that way but me, so don't get confused. All right, so I want to say input shape, I believe, there's just 2 inputs. I also want to have 2 units, 2 nodes, and activation is going to be sigmoid. So now I have created the hidden layer. Yay! The other layer that I need to create is the output layer. And so what am I going to do with the output layer? I don't need to provide an input shape because the input shape can be inferred if I add them sequentially. The inputs are not a layer, so for this first layer, the hidden layer, I've got to say how many there are. But now once I'm creating this next layer, the input shape is going to be defined by what was before it. So now I'm going to say, I really have to stop hitting the sound effects by accident. And now I'm going to say let output equal tf layers.dense. And all I need to say is units, 1, activation, sigmoid. Okay? Then all I have to do is say model.add hidden, model.add output. Okay? So this is the model. Now, one thing I need to do is I definitely need to import the TensorFlow.js library, which I happen to have from one of my previous examples. So I'm going, right now I have the P5 libraries in my index.html plus my crazy neural network thing and my actual code in sketch.js. Someday maybe I'll use the fancy new import syntax stuff. Let me just have everything kind of line up. Let me add this in here. So now tf.js should be there. I should be able to go back and run this and not see any errors. Aha! tf.layers.sequential is not a function. So I probably just didn't name tf.layers.sequential the right thing. You know, I could go look. By the way, I made an example. Oh, it's just tf.sequential. Okay, so all I want to say is I just got that wrong. It's tf.sequential. So, you know, I could go look. You know, hopefully I would find this here. tf.sequential. Yeah, models creation. There it is, tf.sequential. So I just had that wrong. OK, let's try refreshing this yet again. Slider is not defined. All right, let me fix this learning rate issue, 0.1. I just want the thing to run. OK, so it's going. It's still working with the my neural network library, not the new TensorFlow.js one. But let's keep stepping through. So what am I missing here? So when I make a model, now I've architected the model. I've architected this particular architecture, but I need to do another step. I need to compile the model, and I need to define the loss function and the optimizer. Basically, I need to say, like, OK, well, this is how I'm going to determine how well the model is currently performing with the training data. And testing data potentially, but I'm not getting, testing data will come in my next video about classification. But here I'm not making a distinction between training and testing data. I'm conflating those two concepts, which is a big mistake and a problem, but we're stepping through this stuff little by little, like a butterfly flapping its wings. It's not at all like a butterfly, but I felt like I was being like a butterfly. And then an optimizer is what sort of function, what sort of algorithm am I using to adjust all of the weights of all these connections according to the loss function itself. So I need to define those things. I forgot how. I know it's in the thing I made last week, but this stuff just isn't. So let me try to type it out how I think it is, and then we'll go check. So I know I need to create an optimizer. TF optimizer, like this, and with a learning rate, something like this. Like I want to use stochastic gradient descent with some learning rate. That's not correct. This is me like trying to remember what the code is, and then I need to say like model.compile, and then I think when I compile it, I'll say things like this. I'm going to compile it with this optimizer and this loss function like root mean squared or something like that. So this is what I'm remembering from when I looked at this at one time. Now I probably got this wrong. So let's actually go look at the API docs. Well, first, what's the chance that any of this actually makes sense? OK, TF optimizer is not a function. So let's see, how do we create the optimizer? Optimizer. Yes. So it's this is what I want. I want a tf.train.sgd. This is how I create that. The optimizer is not a keyword in the API. I imagine that for myself. So I need to say tf.train.sgd and then give it a learning rate. So tf.train.sgd. And there are other kinds of optimizers that I think I've even shown you and we'll use more, and give it a learning rate like 0.1. Then I want to look at model.compile. Let's look for compile. Well, we can see it in some examples here. What I'm looking for is where the actual compile, there it is, compile. So the compile function compiles it and give it an optimizer, a loss, and I can also do some metric stuff. I'm not going to worry about the metrics too much, although maybe I'll try to come back towards the end of this video. OK, model.compile, optimizer, loss. I think this might actually be fine. Is it root mean squared? So let's look for the loss functions. All right, apologies. I've been saying root mean squared error because I'm stuck in this world where you have to take the square root, which you don't need to do here. So just mean squared error. That's all I need. This is my loss function, mean squared error. Now, let us now go back here, hit refresh. All right, things are happening, things are going. So the model is built, the model is compiled, and the next thing that I am ready to do is now actually start putting data in the model. The two things that we need to do now. What are the two main steps? I don't know why I came over here, but since I'm over here. So first of all, I drew this truth table thing a little bit weirdly. And so you might recall, just to be clear about what's going on, this is my little drawing of the canvas right now. And the idea of the canvas is that I want to see what the neural network thinks false false is at 0, 0. I want to see what it thinks true false is at this top right hand side. The bottom left hand side, I wanted to see it 0, 1, and then I want to see here 1, 1. So false is black for 0, and true is white for 1. That's the way I'm going to map the color. So I should see some kind of bands of like, I should be getting like something like this. So darker here and like this. So let's go look. Does that match? Yeah, that's exactly what I'm seeing here. So the reason why I came over here is there's two things that I need to do. Number one is I need to train the model to produce this output, my desired output that I think it should do. And then I also need to ask the model to predict so I can draw what it thinks its output is. So the two steps here, I'm run out of space, but in the TensorFlow.js library, I need to look at the predict function and the fit function. Predict for just saying, here's the inputs, what is your output? The fit function for saying, here's labeled inputs, inputs with known outputs, optimize yourself according to that. So I'm going to do things backwards. I'm going to do just the predict step first. I just want to see when it starts up with no training, what visual output do we get? So coming back to the code, let's look here. So this is what I need to replace. So now I need to ask the TensorFlow layer sequential model thingy to give me the y. Model.predict. But what does it expect? Its predict function, unlike my predict function, cannot get a regular array. It expects a tensor. So I need to make the x's into tf.train.sgd with those inputs and pass those through predict. Now here's the thing. There's a lot of issues with this that I need to resolve, and this is going to run really slow, and I need to actually do this as a batch process. I'm going to get to all that. But just looking at what I've got so far, model.predict, there's a question of like, is this happen synchronously or asynchronously? This actually is happening synchronously, but the problem is I need to say fill with the result. Like I need to get that number out, and to get the number out, I actually want to call .data, and that happens asynchronously. So because I'm working with such teeny bits of data right now, I think I'm going to use data sync, and there could be issues with that. And as I move more forward, we're going to see when I really need to be more thoughtful about callbacks and promises. But I'm going to use data sync right now. So I should be able to predict the output with this input, get that data, and then let me just say console log y. And I'm going to make the resolution here of the the resolution really big, like 50, because I just want to like look at very, very little data to start with. And let's look. I'm not going to draw anything. Let's just look and see what's coming out. What's coming out here? Y, and then let me just say no loop. So let's look in the console and see if we get anything. Error. Expected when checking dense1 input to have 2 dimensions, but it got array with shape 2. Oh, once again, I have the same problem I've had every single time I've done this with TensorFlow.js. So the good news is I don't want to just give this 1D tensor. Even though my data is just 2 values, 0, 1, 1, 0, 1, 1, and it's a one-dimensional array with 2 numbers in it, I actually want to be able to do something like, hey, take these 15 data points and give me the results, the predictions for all 15 of those. And so what I really want to be doing is I always need to send in kind of like one order higher, one degree, one rank higher. So this actually, I'm just sending in one piece of data input. Brain stopped working in the middle of this video. That's 17 hours long. And this now, I also have to say tensor 2D now, because it's a 2D tensor. There we go. So we can see, look at this. The results came out for all those little spots. You can see little numbers between 0 and 1 in an array. So now I can, instead of console logging y, and I just want that, it comes back in an array, but there's only one number I care about. I can put this back in here. I can take out no loop. And I can run it. And we can see, look, there is my current visualization of XOR. I'm not really done. I have so much left to do in this video that is been recording for the last 3 or 4 days. All right, one thing I want to do is I just want to say stroke 255. So I just want to sort of see a little bit more. OK, that's actually what I'm looking at here. I actually want to make the resolution, for debugging wise, I also want to make the resolution a little bit bigger. So let's see. Now, one thing I'm curious about is let's look at the frame rate here. It's running at 30 frames per second, so that's fine. Let me now actually make the resolution much, much higher, like this. Oh my goodness. Oh, it's not even getting to the first frame. Oh, well, there we go. Look at the frame rate. Oh, it can't even give me a frame rate. It's so stuck. It can't even get 1 frame per second. So here's the thing. I have done something very, very, very bad. And I need it to stop. No loop. Stop. You don't have to do any more work. And let's put the resolution back at 100, and let's think about this. What's going on here? Look at this. Look at this predict function, and look at this data sync function. What am I doing? I am calling that function multiple times for every single spot on that grid. When I'm working with something like TensorFlow.js, whenever I create a tensor or feed data into a model, the data has to go from my code onto the GPU. And then when it's done, that data sync is pulling it off of the GPU so I can use it again in my code. That graphics processing unit where all the math is happening behind the scenes. I want to do that as few times as possible. Look how this is, I'm creating this 2-dimensional array with one thing in it, 100 times. I could just create one array with 100 things in it and call predict once. That's what I want to do. So what I need is for this nested loop to happen twice. Once to set up the data and another to draw all the results. So I'm going to copy paste this, just put it right below. So this now what we need to do is create the input data. So I'm going to say let inputs be a blank array. Then I'm going to say inputs.push, and I'm going to just push in x1, x2. So I'm going to put every single x1, x2 all the way along. I don't want to create the tensor or do this here. I don't want to do the drawing stuff here. I just want to have a loop that creates all of the data. Now, I can get the x's is all of those inputs into a 2D tensor, and the y's, this is now the y's, is, and now here's the thing, so hold on, I got to look at what that's going to look like. Let's comment this out for a second. Let's look at the y's and see what that looks like. Oh, okay, sketch.78 error. Oh, no let there. Just inputs push. Okay, I want to say no loop. Let me leave that no loop in, put it back. I just want to look at it once. So you can see, what did I get? I got a big array of 16 numbers. I got all the results. So now what I want to do is, back here, now I just need to do the drawing. And I don't need the input data, I don't need the model. All I need to do is draw, and I need to say fill y's index what? I plus j times the number of columns maybe? Right? Because this is a one-dimensional array to describe all each spot in that grid. I could do something like, maybe I'll just do this. Let index equal 0. I'm going to say fill based on this particular one. And I don't need this even, sorry. And I just need to say then index plus plus, right? So what are the steps here? Create the data, get the predictions, draw the results, okay? There we go. So now we can see this is working. I mean, it's not doing anything, but now let's check this frame rate question. We don't need to console log the y's. I'm going to get rid of the no loop. Let's refresh this. Let's look at the frame rate. 30 frames per second. Let's pump it up a little. Let's pump you up a little. Where was the resolution there? Let's make this 20. Don't want to go crazy. And look at the frame rate. There we go, 30 frames per second, no problem, because I'm only one time through draw trying to copy data onto the GPU and get it. I'm only calling predict once. And we can, just to check, we can go to 10. And we can look at the frame rate. And you can see it's like kind of running a little bit slow, but this is because I'm not being too thoughtful about the asynchronous nature of this stuff. I could do other things to optimize it, but I'm just going to ignore that and leave it at, let me make it 25. The chat is giving me some even further optimization, which is, why am I bothering to do this in draw? This is something that these inputs never change. I can just do them once at the beginning because they're, and I can ask for them many times in draw. So let's actually fix that. So I'm gonna take this and say I'm gonna make these global variables. I don't know if you guys can hear the music that's coming from the room next to me, but it's there. All right, then. But the width and height does not exist until after create canvas. So let me do this. And let me do this. OK, so now that's there. Now I should be able to take this, the input data, and put this right here at the beginning. And then I'm going to make a variable called x's. And x's, and where did I do that? Here. And then create those x's. So I'm now doing this in setup. And then in draw, the only thing I need to do in draw is run the predict. This is going to make things run a lot faster. Let's make sure it still works. Here we go. OK, so you notice we get like a different color each time I refresh because the neural network model, the sequential model, is initializing everything randomly. But now I get to train it. Yes! Now I think we're ready to train it. So here is what I did when I had my own JavaScript neural network library. I called neural network.train data.inputs data.outputs. All right, so if only I could remember exactly what I wrote when I made that TF layers tutorial, but I know that what I need to do here is I need to do something like this. Model.fit some x's and some y's. That's the training, that's the equivalent, and the learning rate is irrelevant. And I don't necessarily need to do a loop. This is basically what I want to do. Every time through draw, I want to try to fit the model with some training data. So let's first make the training data. This is not exactly right. I need to figure out, and I need to use a weight. I need to think asynchronously, but this is the idea. So if I go back to the top here, this is my training data. Now, one thing I definitely need to change is I'm going to keep the x's and y's separate in training. So I'm going to do this is, I'm just going to do this kind of manually, because what's the big deal? So let me make the training set. And then 1, 1. Those are the x's. Now let me look at the y's. And the y's would be 0, 1, 1, 0. Then I need those to be tensors. So I need to say const tf x's. So I'm trying to think of good naming for this. I kind of want them to be called, actually, you know what? I'm just going to call it, do I have a global x? Yeah, I have a global x's already. TF x's equals tensor 2D, tensor 2D, oh, TF, tensor 2D. You know what I'm going to do? I don't need these, I don't need two separate sets of variables. I'm just going to create it. I'm going to call this, everything is so much more complicated than I make it. So much more simple than I make it. I'm just going to make these tensors directly by saying tf.tensor 2D. And then I'll put the parentheses around this. And there, now I made it a tensor. Then I'll say tf tensor 2D. And now I made this a tensor. OK. Now we're good. I've got the training data. And I'm going to get rid of this. This is the old way that I had the training data, which is totally unnecessary. So the training x's and the training y's. Are you with me? How have you been watching? If you're still watching, I don't know. Get up and do some jumping jacks. Let's see. Now, I need to do model.fit. Now, model.fit happens asynchronously. So let's put it in its own async function called train model. Now, if you don't know what it means to write a function that is tagged with the keyword async, this is part of ES8, a very newish version of JavaScript. And I made a bunch of videos about what that is that you can go back and watch. But this is basically a way for me to now say await model.fit. And then let's look at the fit function. Model.evaluate, compile, predict, fit. So what I need is to give it the x's and the y's. There's batch size I'm not going to worry about. There's epochs I'm not going to worry about, or epochs. And so h will give me back the history. So let's just see here. I'm now going to say train model.then h console.log h.loss index 0. Let's say no loop again. So basically what I'm doing here is I want to call this function train model, and I'm using this idea of promises. It's going to await the model. Oh, and I need to return. Do I say await return or return await? No. I must say return await. Return await model.fit. So I'm going to return a promise which will have the result of the fit function. And I don't know if this is right. I want to just look. I want to do that. I want to call to train model every time in draw. I might need to do this somewhere else just for right now and then see what the loss is. OK. Onyx 73. Async function. Async function. I've got to say function. Function. It's an async function, not an async. There we go. Y's is not defined where? In train model. Oh, right. This is, I forgot, I called it train x's and train y's. So my training data, train x's and train y's. Isn't it nice how the word train just appears everywhere when you're doing machine learning? Drink your glass of milk or whatever it is you're having while you're watching this coding train stuff. Cannot read property 0 of undefined a train model then h. All right. Let's just console log h. I don't know what that is, what I've done. Okay. History, loss, 0. Okay. I wonder what it, by the way, I didn't give it any testing data. So what's it computing the loss from? History. So this is, I'm going to call this result. Result, history, dot loss, index 0. All right, there we go. There we go. Now let's let it do that over and over again in draw. So I let this run a little bit, and unfortunately you can see it's getting nowhere. This loss, which I'm not sure exactly how it's calculating that, I'll think about that and come back to it, is not going down anymore. So what could be some problems here? Number one is, well, maybe my learning rate is no good. Not that it's no good, but maybe it's too low. So where did I set up that learning rate again? And let me get rid of, by the way, I just want to now delete. I want to make sure I'm not using any of my old neural network code. So I'm deleting all references to that. So this is now purely TensorFlow.js, and let me refresh and run this again. And let me look into sketch.js and find where did I set the learning rate right here. Let's set it to 0.5 and see what we get. Yeah, it's getting better. I'm going to let this run for a little bit and I'll be back. All right, I'm back, and you can see the loss is now kind of much lower, and you can start to see the visual that I'm expecting, which has a true value in this corner, true value in the top corner, and sort of darker false values in those corners, but it's still kind of performing rather poorly. One thing that I forgot to do is when I call the fit function, there are a set of options that I can pass in for the number of epochs and all sorts of things. But one of the ones that I really want to pass in here is called shuffle. Shuffle takes the training data and it shuffles the order of it each time. Right now I'm training it with the same 4 data points in the same order every time, which could be a bit of a problem. And okay, so let me now, let me hit refresh here and run this again. All right, so it actually is working. It got the correct training result. It's a little grayscale-y in a way that I would like to be able to emphasize visually what it's doing. But you can see the loss has gone way down, but it took a while to get there. But I want to add a few things to this and try to fix it up a little bit. But before I do anything, I was reminded by the chat, being over here, that I haven't thought about memory management at all. So I'm going to say no loop for a second to just sort of turn this off. Then I'm going to say memory num tensors. Oops, no, wait. tf.memory dot num tensor. I know I'm trying to use, I'm going to say num tensors. tf.memory num, there it is. There it is. I can get it. There it is. 32,205 tensors. That's crazy. So I need to deal with that. I'm just making tensors and letting them leak everywhere. So I could manually run dispose, but I've got kind of an issue, whereas predict is going to make a lot of tensors behind the scenes, as well as model.fit. So I can use the tf.tidy function. So I'm going to say tf.tidy, and then I just need to, I'm going to use the ES6 arrow notation, which you can watch my videos about what that is, and I've kind of gone through what tidy is. Tidy says anything inside of this code, clean up the memory afterwards, basically. And then I probably could put this around everything, but I just want to, and I don't need this stuff anymore, I just want to keep these 2 areas separate because I think I'm going to, at some point I really should change the way doing the fitting of the model, in draw is somewhat problematic. So now I'm going to just tidy all of this. I think that's right. Do I have an extra parentheses there? Yes. Okay, so now let's run this again. And let me comment out this console log. I don't want to see that right now. Oh. All right, and now let's look at the number of tensors. 15, 15, 15. So now I've gotten rid of the memory leak. Let's check out the frame rate. 30 frames per second. So this is running for a while. Now, I just want to be able to look at what's happening a little bit better. So I'm actually going to draw the number of the output inside each one of these things. So let's do that. So where am I drawing? The rectangles here. I'm going to say let the brightness value equal this. And I'm going to fill the rectangle with that brightness. And then I'm going to say fill 255 minus, like the inverse color. I'm going to say text. Number format, the y values index with just 2 decimal places, and I'm going to put that at, boy, this is awkward. The x values, this is going to be I times resolution plus resolution divided by 2. I'm going to say text align center, text align center, comma center, and then I'm going to put I'm just going to draw in the center of the rectangle, and this should be J, the text. So let's do this now. So we can see, ooh, look, there's lots of numbers there. I think my number format thing didn't work. 1, 2, and let's use a lower resolution just so I can see it better. There we go. Now, interestingly, I can't see the numbers, but there they go. Right? You can see this is what it's getting, the output for each one of these. And I want to look at the loss. You can see, because it's just going so slow. It's getting a little better. It's getting a little bit better. So over time, it's getting a little better. But I really want to see it train much faster. So let me see. I have one idea, one last thing I can add to this, even though I have some suggestions for what you might do next. But you can see, the numbers are starting to appear. Lovely. Because I forgot when it's gray, when it's at 0.5, 255 minus 0.5, it's going to be the same color. But I kind of like that effect. So, so what I want to do is, what happens here if I actually tell it, don't just do it once. Like do it 10 times. Do 10 epochs per cycle of fitting. Let me run this again. And let me look at let's actually have the loss continue to print out. And there we go. Still running pretty fast. You can see the loss is going down. And relatively quickly, I am getting myself to the point where I'm starting to see, this is definitely getting all the way down to 0 there. This is getting way up to 1 there. It's getting a little bit stuck. It's having trouble with this side. I imagine we'll get there eventually. We could do some fun stuff. So I'm going to give it, for no real reason at all, but just for fun, 4 hidden nodes. And I'm also going to, let me change the resolution to 25. Let me make the text size something like 8 point. And let me, oops. Refresh it. All right, I let this run for a bit, and you can kind of see here. Now you can see all the XOR values. Here's a nice, beautiful little map, grayscale map of all XOR. It's getting all the way up to true and all the way down to 0 at the corners. This is pretty good. So, and this is running at, if I take out this console log, I can now take a look at the frame rate. It's running kind of slow. All right, so the chat has given me some really helpful tips. I've made quite a few little weird little errors and mistakes here, and I want to just fix this up a bit. I think it's actually going to be easier to look at and watch if I just go back to a lower resolution. So let's make this 40, and let me refresh this. Okay, so here we go. So this is now working, training itself for XOR. You can see it's kind of moving along here. Now, what the real thing that's problematic here is the draw loop is happening over and over again. And then I'm triggering something asynchronous in draw, and I could be asking to train the model before it's even done with the previous training cycle. So this really should not be happening in draw. Now, TensorFlow.js has a function called tf.next frame. I want you to explore it and make a version of this with tf.train as like an exercise after this video is over. But I'm going to do it a different way without that because I got to come back to that in a different video. But first of all, this I also learned, this is totally unnecessary. The await, a couple things. Number one is, because there's just one thing happening in here, I could just return the promise. This doesn't actually have to be an async function. And then I do not need the tf tidy because model.fit kind of will clean itself up automatically for you. So this should still work just fine. And I should be able to see the number of tensors is still 15. So that was something that I didn't need that I've now fixed. Now what I really want to do is I want to get this out of draw. So let's comment this out here. And what I'm actually going to do is I'm going to write a separate function called train. And in that function, I'm going to say set time. OK, wait. I'm going to call train model. Wait, hold on. I'm going to call train model. Yes. In that function, I'm going to do this. So I'm going to separate function that does this piece of it, that console logs the history. And I could use, and what I want to do is I want to say set time out, call the train function in 100 milliseconds. So I want to just let the program start and say 100 milliseconds later, call this train function. Train the model, which does the fitting. When that's done, log the history, and now say set time out, train 100. So I'm good. This is sort of like recursion. I don't want to use set interval here because I only want to call train again once it's finished with training the model itself. So this is kind of like, hey, train. And by the way, I could just increase the number of epochs or maybe do some kind of loop. But I think this will be a sort of nice way to demonstrate it. And if I just called train directly, without a set timeout, I'm never going to be giving back control for a second. I could end up with sort of like blocking. So I might even be able to get this down to like 10 milliseconds, just something really, really low. So let's run this and sort of see. Same result. We can see, there we go. Things are working, but at least now I have gotten that out of draw. So draw is happening on its own. And in fact, what I could really do is I could say, hey, try doing this with like 100 epochs each time. Epochs? What is it? And you can see the loss function is coming out much more slowly. But whoops, but the frame rate, let me just clear this for a second. The frame rate is quite fast. Hold on, this is too confusing. I probably need to give it back more time. Let's do like another little break. I just want to like take out the console log thing so I can look at the frame rate. I should just put the frame rate in the DOM. Wouldn't that be smart? But you can see now I'm getting 60 frames, 30 frames. Well, I'm getting like a pretty high frame rate, even though the training is happening. It's kind of like there is no threading in JavaScript. So these things are just like passing off. And really, this might be a place where like web workers or something could do the training behind the scenes in some fancy way, which maybe I will get to at some point. Oh my goodness. Alka is suggesting it might be better to use the draw loop and a Boolean to know when it's safe to call it again. That would also be a good idea. So you can see what kind of like, I'm pulling my hair out, what kind of sort of like hassle situation we've gotten in. But really, let's just put this back to like 2 epochs. Let's put this to like little 10 milliseconds. And we can sort of feel like, there we go. And I can look at the frame rate. It's running nice 30 frames per second, and even though, and at some point it's going to get there. What's that loss? I forgot to console log the loss. Come back to me. Come on. Oh, but let's see. I have an idea. What if just before I go, what if we try using a different optimizer? What if we try using, for example, a different loss function? Hold on. This video is already 18 hours long. What if, oh no, a different optimizer, sorry. What if I tried using the Atom optimizer? So let's just try that just for fun times. Let's give it a lower learning rate. Yeah, wow. All this time. That was pretty exciting. Let's go, let's make the resolution back to like 20. Let me make the font size like nice and tiny for us. Let me give myself some more space here. Hit refresh. And then let's look at this. Look at it learning there. Ah, look at that. That is beautiful. Look at it learning. XOR is so nice and fast. I'm just going to hit refresh again. We can see it. All right. I really should explain what these optimizers are, but if I go back and look under here, we can see what some of these are. Atom, the ADA coming from the word adaptive, and you could always click here and look at this paper, which describes this particular method for optimization, which is a little bit different than stochastic gradient descent. And apparently, things work a lot faster with this XOR problem. So as I go forward into more of these videos, hopefully we can dig into what some of these different optimizers do and kind of understand why I might pick one over the other in certain situations. All right, but I'm just going to leave this be. I'm going to hit refresh. I'm going to watch it learn and train. Train XOR. I don't know, some things you could do. Investigate tf.frame. Give me a little slider. Try different architectures, different optimizers. Try some different activation functions. I don't know. If you actually made it all the way to the end of this video, I don't know, hashtag something. Eric is telling me to watch one of those videos reviewing the JavaScript event loop, which I definitely need to do. So I'm going to be back with more someday. Goodbye. Thank you.